Hello everyone. In this video, we are going to see how do we solve the improper integral. Okay. So for that, first it's important to understand what is the improper integral. Here we are going to discuss two type of improper integral. First is when the interval of integration is not finite. This is the type 1 of improper integral. For example, if you see the limit of the integral, here the upper limit is infinity. So this is an improper integral. Another example, you can say minus infinity to 1 of say x dx. So again, you see here that the lower limit is infinite. So again, this is an improper integral. Okay, so these kinds of improper integrals are called type 1 of improper integral. What is other type of integrals that we call as improper integral? The integral where the integrand, the function that you are integrating, is unbounded over the given interval of integration. So for instance, take this example, integral minus 2 to 1 over x plus 1 dx. So this is your integrand. Okay, so if we look at this, 1 over x plus 1. So this will become infinite if x plus 1 is equal to 0. The denominator becomes 0. So this gives you the value of x as minus 1. So it means at x equal to minus 1, this integral become indefinite, unbounded, sorry. So what happened here? You have the integral over the interval minus 2 to 1. And this point x equal to minus 1, it lies in between. So at this point, the function become the unbounded. So this type of integrals are called the improper integrals of type 2. Okay, so in this video, we will see how do we solve first the integral of type 1, and then another video you will see how do we solve the improper integrals of type 2. So when we work with improper integrals of type 1, what we see integral are called improper of type 1 if the limit of integrations are infinite, like one of the limit is infinite. So what we do? Suppose the function is continuous in this interval a to infinity and the upper limit of integral is infinity. Then what we will do in place of infinity, we use another variable, say b, and then we take the limit of this b as b tends to infinity. Okay, so let us take this example. So look at the first question. What you see? Integral 0 to infinity dx over 1 minus x squared. Here the upper limit become infinity. So the first thing we have to do is to rewrite this question in the form of limit. So we write limit, since upper limit goes to infinity, we use a variable in place of infinity and we write integral 0 to b dx over 1 plus x squared. So now what you see over here, that this integral become a definite integral. So you will now answer this part as a definite integral. So for this, what we are going to do, we have to use a rule. So what the rule says? Rule says that integral of dx over a square plus x square is 1 over a tan inverse of x over a and plus the constant of integration c. So in place of a square you have here 1. So 1 is same as 1 square. So in this case your value of a is 1. Okay, for this formula. So what you can do now, what will be the integral of this? So if you write it, this will gives you, yes, this is equal limit b goes to infinity. Integral of this will be 1 over 1 tan inverse of x over 1, or you can say tan inverse of x from 0 to b. These are limits for x. So replace x by b and then x by 0. So this gives you limit b goes to infinity tan inverse of b minus tan inverse of 0 by substituting the limit. We always substitute the upper limit first and then the lower limit. Now, tan inverse of 0, if you check by calculator, it gives you 0. So limit b goes to infinity, we left with tan inverse of b. Now, what you have to do now, this b is approaching to infinity. So just substitute the value. This gives you tan inverse of infinity. And we know that when the value of tan of theta becomes infinity, it's at 90 degrees. So it will be at pi by 2. So we can say that the value of this integral is pi by 2. Okay. So in the same way, if you look at question number 2, again the upper limit is infinity. So what you can do, only thing you have to do is write it in the limit form. Limit b goes to infinity. You can use any alphabet. You may use here a. Okay, so this becomes 8 to b dx over cube root of x to the power 4. It's always better to write it in a simplest form before you do the integration. So it becomes integral 8 to b. So this is dx over x to the power 4 over 3. We know that whenever we have a term like this, we always bring it in the numerator. So this gives you limit b goes to infinity 8 to b x to the power minus 4 over 3 dx. So this gives you limit b goes to infinity. Integrate this term. So here you can use the rule of integration. Integration x to the power n dx is n plus 1 over n plus 1 plus c. C for indefinite integral. See this, we can use this rule because n is not equal to minus 1. So when we use this rule, we will get x to the power minus 4 over 3 plus 1 over minus 4 over 3 plus 1. And the limits are from 8 to b. Okay. So this gives you limit b goes to infinity. So this will become what? Minus 4 over 3 plus 1. This become minus 1 over 3. So x to the power minus 1 over 3, and here in denominator also minus 1 over 3. So this gives you minus 3, and x goes from 8 to b. So now substitute x, replace x one time by b and then by a. We will get limit b goes to infinity minus 3 b to the power minus 1 by 3 minus plus 8 to the power minus 1 by 3. Now, what is next? B is approaching to infinity. So this goes to infinity. And what you will have? This is to the power minus 1 by 3. So you can write it as minus 3 over infinity to the power 1 over 3 plus 3 over 8 to the power 1 over 3. So 3 over infinity. Any number over infinity is 0. Plus 3 over 8 to the power 1 over 3. The cube root of 8 will be 2. So you get your answer as 3 over 2. That will be your limit. Okay. So what is another possibility? Other possibility is that lower limit is infinite. So in this case, if a function is continuous in the interval minus infinity to b, and you have to evaluate integral minus infinity to b fx dx. So what you will do? You just replace this lower limit by an alphabet and use it as a limit. Limit a goes to minus infinity, integral a to b fx dx. Okay, so it's the same thing now. So if you look at this question number 4, sorry. So what you see here, the lower limit of integration is infinity. Okay, so how you can write this? You can write this integral. Let me solve it here. You can write this integral as limit. Use an alphabet. Say a goes to minus infinity. Integral a to 0 e to the power 3x dx. Okay. So make sure you are writing here minus infinity. A approaches to minus infinity. Okay. Now what you have? You have this integral. This is a definite integral. So you can use the exponent rule if it is integral of e to the power ax plus b. So e power ax plus b will be the same and you divide it by the coefficient of x. Okay. So here the coefficient of x is 3. So when you integrate, this gives you limit a goes to minus infinity e to the power 3x divided by 3. And x is from a to x is equal to 0. Now just replace this x one time by a and another time by 0, substituting the limit. So this gives limit a goes to minus infinity e to the power. When you replace x by 0, so 3 multiply 0 gives you 0 over 3. And e power 3a over 3. Okay. Any number raised to the power 0. So this value will be 1. Substituting this gives you limit a goes to minus infinity 1 over 3 minus e to the power 3a over 3. Now what you have to do? You have to substitute the limit. Replace a by infinity. Replacing the limit a by infinity. So this gives you 1 over 3 minus e to the power. Minus infinity multiply any number gives you minus infinity. Okay, and then you need to remember that e to the power minus infinity is 0. Why? Because e to the power infinity is infinite and e to the power minus infinity is 1 over e power infinity, which is 1 over infinite, and 1 over infinite is 0. So this term becomes 0. So 0 over 3 again 0. So this gives you your final answer as 1 over 3.